So we are moving to the next question. That is question number 52 in your section A. Question is electrolytic cell is composed of copper and zinc. Okay, so there is an electrolytic cell which composed of copper and zinc. Ready? A current of 9.65 amps is drawn for the from cell for 1 hour. Okay. Then loss of mass in anode and gain of mass in cathode. Let we have an electrolytic cell which composed of copper and zinc. That is two electrolytic cell. It's not galvanic cell, electrolytic cell composed of copper and zinc. Let this be the zinc which can lose electron, copper. So once zinc loses electron, what happens? Zinc become Zn2 plus, so that the mass of electrode will be decreases. And once copper gains electron, Cu2 plus absorb electron from electrode, so that copper deposited on this electrode, which means the mass increased. Whatever it may be, if they are seriously connected, if the same quantity of current passed, we know that both have deposition proportional to their own equivalent mass. Anyway, first of all, we can find the weight deposited here. That is, weight is equal to equivalent mass divided by 96500 into current into time. So equivalent mass of zinc, the N factor of zinc is 2. The mass of zinc is 65.3 divided by 2 is the equivalent mass divided by 96500 into the current is 9.65 amps, correct? Yeah. And that is for 1 hour, right? Since it is 1 hour, 60 into 60 seconds. So by solving this, we obtain a value, okay? And what will be the weight deposited or weight gained? Here the mass lost and here the mass gained. Mass gained in copper, W is equal to E by 96500 into IT, that is the same equation. But equivalent mass of copper is copper having molar mass of 63.5, whereas zinc have 65.3. See the difference. But the N factor is remains same too. So this is 63.5 divided by 2 divided by 96500 into current is same current is passed because seriously connected. So it is clear that there is a small difference, right? Yeah, the answer is nearly same. The mass gained and mass lost nearly same, so there is a small difference. So by looking at the choice, no need of solving this one. It is clear that your choice will be 1, okay, because the values are nearly same, 11.77, 11.43. Okay, it is clear that copper have, this may be the lower value compared to this one, because here 65.3 in numerator, 63.5 in numerator. Okay, so it is clear that we can choose a choice as 1. No need of solving. Okay, this is objective question. No need of final answer. If you know this will be the answer, you can choose that. Okay, by anyhow. Steps are not required. So question number 53. Volume of gas evolved when dilute sulfuric acid is electrolyzed using 2 farad. Okay, we know that when dilute sulfuric acid electrolyzed, which is the reaction in anode and which is the reaction cathode? It is already discussed. When dilute sulfuric acid electrolyzed, cathode have hydrogen and anode have oxygen. Ready? So in your cathode, what happens? Cathode, 2H plus 2 electron gives H2. This will be the reaction cathode. Okay, and what you are asked to find? Volume of gas evolved when dilute H2 for electrolyzed using 2 farad at STP. Volume of gases. So you have to choose the gas if the gas is in cathode and if it is the gas is in anode also. Okay, so it is not specified that volume of hydrogen evolved in anode like that. Volume of gases, simply gases. It may be anything in this reaction. So we know that in cathode, hydrogen will be evolved because the reduction is for water. Since the reduction is for water, this will be the reaction, and it is clear that here the electron involved is 2. So 2 farads applied, 1 mole hydrogen liberated. 1 mole hydrogen liberated means 20.4 liter hydrogen at STP will be liberated at a cathode. What about the reaction in anode? We already know that since we know the concept of product of electrolysis, we know that in anode, oxygen will be oxidized. So O2 minus become half O2 by the liberation of 2 electrons. And it is clear that if 2 farads applied, half O2, which means half mole O2 liberated. Half mole O2 means 11.2 liter oxygen at a anode. So what is the total volume of gas when 2 farad current is passed through diluted H2SO4? Total volume will be 20.4 from your hydrogen and 11.2 from your oxygen, that is 33.6 liter. Okay, so your choice is 3. Ready? So the next question, that is question number 57. Okay, question number 57. So let's have a look into the next question number 57. Ready? Okay, so read the question. That is, if equal quantity of electricity are passed through 3 voltmeter containing FeSO4, Fe2SO4, FeNO3, then what is the question? Then which of the following is not true? The same current passed through electrolytes like FeSO4, Fe2SO4 thrice, FeNO3 thrice. Then which of the following is true? That is the question. Amount of ion deposited in FeSO4 and Fe2SO4 equal amount of ion deposited in FeNO3 2 by 3 times of. Not true is asked. Listen, what is the form of ion here? Fe2 plus. So equivalent mass is equal to molar mass divided by 2. What is the form of ion here? Fe3 plus. So equivalent mass is equal to molar mass divided by 3. Here the form of ion is Fe3 plus itself. You know how to calculate the ionic charge. So equivalent mass is equal to molar mass divided by 2. And we know that if 3 electrolytes are seriously connected, then if same quantity of current passed, then the deposition proportional to their own equivalent. Since the equivalent mass of these two are same, the deposition in these two containers will be same. Right? Yeah. Deposition proportional to their own equivalent mass. Since the equivalent mass of Fe2SO4 thrice and FeNO3 thrice are same, the deposition will be same though. But it is not equal to the deposition in your FeSO4. Okay, what about the question? Choice number 1. Amount of ion deposited in FeSO4 and Fe2SO4 thrice will be equal. Never. Since equivalent mass are different, the deposition will be in a different rate. So I think the choice will be 1. Okay, let me discuss the next also. Amount of ion deposited in FeNO3 thrice is 2 by 3 times of amount of ion deposited in FeSO4. Okay, so amount of ion deposited in FeNO3 thrice is 2 by 3 times of FeSO4. So 2 by 3 times of mass deposited in FeSO4 means it is something like m by 3. And this 2 by 3 times of mass deposited in FeSO4 will be equal to the mass deposited in FeNO3, means it is correct. 2 by 3 times of mass deposited in FeSO4 is 2 by 3 times of m by 2, which means m by 3. Correct? M by 3 will be the case. So that is okay, fine. Amount of ion deposited in Fe2SO4 and both are equal. Fe2SO4 thrice and FeNO3 thrice both are equal. Fine. That's also correct. Correct. So 2 and 3 are correct. For what about the 4? The same gas is evolved when 3K is at anode. Yeah, that's also correct. Because if you electrolyzed SO4 2 minus, here also SO4 2 minus, and here also NO3 minus. We know the section product of electrolysis. If polyatomic ion cathode with the deposition will be ion, okay? So that's also correct. Fine. So what about the next question? So the choice wrong is 1, okay? The next question, that is not in your section A. The questions from your section A is over. So we are moving to the section B. And in your section B, the question number 4. Let's have a discussion about the section B, where the first question in your electrolysis is question number 4. Okay. So what is the question number 4? During the electrolysis of molten sodium chloride, the time required to produce 0.1 mole of chlorine gas at a current of 3 amperes is time required to produce. Fine. During the electrolysis of molten sodium chloride, so here we electrolyzed molten sodium chloride. Okay, so at anode, the reaction is 2Cl minus gives Cl2 plus 2 electron. Okay, ready. So there is some kind of liberation of chlorine in your anode. No problem. We know that. Okay. So what here asked? The time required to produce 0.1 mole of chlorine gas using 3 amperes current. Okay. So 0.1 mole chlorine means the mass will be 0.1 into, since the Cl2 the mass is 71, 7.1 gram will be the deposition or liberation of chlorine. Agreed? And we know that W equal to E by 96500 into IT. And here the current supplied is 3 amps. And equivalent mass of chlorine we know 35.5 divided by 96500 into current is 3 amps. And you are asked to find the time. And here it is 7.1. Okay. So this can be cancelled. And 71 into 10 raised to minus 1. 71 into 10 raised to minus 1. So 2 into 10 raised to minus 1 here. This is multiplied to here. Okay. So the time is equal to 2 into 96500 into 10 to the power minus 1 divided by 3. Divided by 3. So this is 9650 to by 3 times. 2 into 965, I think 965 into 2. 0, 12, 13, 19. Divided by 3. Divided by 3. Okay, if it is 200, 100 have 60, 100 have 33, 66. What is a 66? 193 divided by 3. 65 into 3. What it is? 5, 1, 9, 195. So nearly, I think at 64400 seconds. Divided by 60. Nearly 110 minutes. Yeah, the choice is 110 minutes. Okay, ready. The choice is 110 minutes. And you can solve that, okay? What about the next question? Question number 5. Question number 5, that is, the number of electrons delivered at cathode during electrolysis of 1 ampere current for 60 seconds Number of electron delivered at cathode during the electrolysis of 1 ampere current for 60 seconds. We know that charge will be the integral multiple of electron. Ready? So the number of electron delivered is calculated by charge divided by charge of electron. The charge is IT divided by E. So the IT here is 1 into 60 divided by charge of electron 1.6 into 10 raised to minus 19. Okay. So 60 into 10 raised to 19 divided by 1.6. Every 16 was simply written as 16 into 10 to the power minus 1. So this is to the top. 60 divided by 16 and raised to 20. 16, 16, 16, 16, 16. Tell me. 48, 3. Okay, 12. 12 is 12 by 16. 3 by 4. So 3.75 into 10 to the power 20. 3.75 into 10 to the power 20. Your choice is 3. Okay. Your choice is 3. So this will be the number of electrons delivered when 3 amps current passed for, 1 amps current passed for 60 seconds. Okay. Moving to the next question, question number 10. When 0.1 mole of MnO4 minus is oxidized, the quantity of electricity passed. So here is the oxidation of MnO4, manganate ion, MnO4 minus 2 to MnO4 minus. Okay, this is an oxidation. We know that the oxidation state. Here it is the oxidation of Mn6 plus 2, Mn7 plus. Ready? Agreed? Okay. So this is the reaction involved here. And what are you asked to find? When 0.1 mole of MnO4 minus is oxidized, the quantity of electricity required in terms of farad or coulomb. So it is clear that the electron involved is 1. So 1 farad first 1 mole MnO4 2 minus oxidized. Since 1 electron involved means 1 farad past 1 mole reaction takes place. Okay. Therefore, in order to oxidize 0.1 mole or MnO4 minus 2 minus, we required 0.1 farad. 0.1 farad means 96500 coulomb is enough. Sorry, 9650 coulomb is enough. Okay, the choice is 3. This kind of questions are already discussed in your examples, okay, in your theory. So moving to the next question. The question that is question number 11. The weight of silver displaced by the quantity of electricity passed. The weight of silver displaced by a quantity of electricity which displaces 5600 milliliter of oxygen at STP. So you have a quantity of electricity Q which is able to displace 5600 milliliter oxygen at STP. Then if you are using that quantity of electricity, then how much weight you can displace of your silver? That is a question. So first of all, you want to find the quantity of electricity used here from this data, and you apply that quantity of electricity to the silver, then you find the mass displaced or the weight displaced. Fine. So we know that O2 minus, when it become oxidized, it become half O2 plus 2 electron. And it is clear that electron involved is 2 and the coefficient is 1 by 2. So 2 farad supplied, half mole O2 oxidized. 2 farad supplied, half mole O2 oxidized. Ready? If so, half mole O2 oxidized means 1 11200 milliliter at STP. Therefore, if 1 farad passed, it will be 5600 milliliter at STP. Actually, we required this, okay? So, in order to liberate 5600 milliliter at STP, actually the current required is 1 farad. So, if you have exactly 1 farad for silver, what is the weight deposited for silver? We know that Ag plus become Ag using 1 electron, which means 1 farad passed, 1 mole Ag deposited. 1 mole Ag deposited means 108 gram deposited. So actually we used 1 farad here. So 1 farad is used, 108 Ag deposited. So the answer will be 108. You can choose the choice as 4. Okay. So from this data you want to find the current, and using that current you can find the weight of silver. That is the question. Okay. It's a good question. Moving to the next question. That is the question number 27. Question number 27. Fine. Question number 27. Let me read the question. In your section B, okay? Question number 27. Al2O3 is reduced by electrolysis at a low potential and high currents. If 404 amps current of passed through molten Al2O3. Okay, so we have Al2O3. Ready? The current passed is 4 into 10 raised to 4 amps. Ready? And the time is 6 hours, which means 6 into 60 into 60 seconds. What is the mass of aluminum produced? You simply find the mass of aluminum, and the current efficiency is 100. So in an ideal case, we already choose the current efficiency as 100. So no need of considering that. If the current efficiency is 50, like that is mentioned, you have to consider the current efficiency. I think we discussed that kind of problem. So here you simply find the weight deposited. Weight of aluminum deposited. Okay, and the molar mass of aluminum is given, and we know that in your Al2O3, your aluminum exists as Al3 plus. So the equivalent mass is molar mass divided by N factor. The molar mass is 27. So N factor is 3, we know, since the cationic charge is 3. So equivalent mass is 9. So E divided by 96500 into the current is 4 into 10 raised to 4, and the time is 6 into 60 into 60. Okay, I already told you that this value you can choose it as 0.04 into your numerator 0.04, and equivalent mass is 9, right? Yeah. So 9 into 4 into 10 to the power 4 into this one is 0.04. Okay, 0.04 means 4 into 10 to the power minus 2. Ready? So this is cancelled 10 square. So 4 into 4, 16. 16 into 9, you want to calculate, into 10 square will be the weight deposited. 16 into 9, I think the 16 into 10 is 160. So minus 16. 160 minus 16 will be 144. So 1440 will be the answer. Sorry, 400 will be the answer. Let's have a check. It is not given. Oh, this 6 is not taken. So here is a 6. The rest is same. So let me do once again. So 9, 4, 10 to the power 4, 6, and this much is 0.04. Okay, so 4 into 10 raised to minus 2. And that 10 raised to minus 2, 10 raised to 4 is cancelled. So 10 square will be the remaining. Okay, so this is 9 into 4 into 4 into, 9 into 4 into 6 into 4 into 10 to the power 2 is the remaining one. Okay. So 4 into 4, 16. 9 into 6, 54. So 54 into 16 into 10 square. So what is the answer? 54 into 16. 54 into 16, 4 into 6, 4, 2, 30, 32. 4, 5, 4, 6, 8. Okay. So this is answer. So this can be written as 8.64 into 1, 2, 3, 4. Okay, 10 to the power 4. Fine. So the answer will be choice 1. Okay, 8 point. 8 point will be the answer. Ready? So 6 is not written. That is a mistake. So, next question. In your section B, that is question number 36. 4.5 gram of aluminum deposited at cathode from a L3+ solution by a certain quantity of electric charge. And the volume of hydrogen produced STP from H+ ion using the same quantity. So that's a simple question. So there is a quantity of current, and you asked to find the deposition of H+2 or liberation of H+2, H2. Or you simply find the deposition of liberation of hydrogen from H+ using that particular quantity of current. And that quantity of current is exactly used for the deposition of 4.5 gram of aluminum actually. Yes, so let's find what is that quantity of current. 4.5 gram of aluminum deposited means we know that 1 farad passed for aluminum, equivalent mass 27 divided by 3, which means 9 gram deposited. Okay, so to deposit 4.5 gram aluminum, you require half farad. So if half farad is passed, how much hydrogen is liberated at STP? That is the question. We know that from this reaction, 2 farad passed 1 mole hydrogen, which means 20.4 liter. So half farad passed 1/4 mole hydrogen, which means 5.6 liter hydrogen. So the answer will be 5.63. Okay, ready? Moving to the next question. That is the question number 2. Sorry, 2 is no. It's not 2, 42. How many grams of cobalt metal is deposited when electrolysis of cobalt 3 chloride is of current 10 amps 109 minutes? Okay. And atomic mass of cobalt is given. Okay. So this is cobalt 3 chloride. Cobalt 3 chloride means COCl3. The state of cobalt is 3+. Okay, and we know that if cobalt is deposited, that CO3+ should accept 3 electrons to deposit CO. To deposit as CO. So we want to find the weight. Yeah, the weight. So the weight is given by equivalent mass divided by 96500 into current into time. Equivalent mass of cobalt, that is its molar mass divided by 3, since the n factor is 3. So the molar mass, I think 59. Yeah. So 59 divided by 3 divided by 96500. What about the current and time? Current is 10 amps and the time is 109 minutes. 109 into 60. All this, I think we obtain 4 gram. Check it. The choice will be 2. Okay. So the question number 43, or the last question from your electrolysis. Last question from your choice, section B. That is, a 5 ampere current is passed through a solution of zinc sulfate for 40 minutes. The amount of zinc deposited. So the deposited weight is equal to equivalent mass divided by 96500 into current into time. Okay. So the current 5 amps, equivalent mass of zinc is 65.3 divided by 2 divided by 96500 into the current is I think 5. The time is 40 into 40 minutes means 40 into 60. Okay. So the half of 65 is 32.5. And if 96500 to the top, it is 1.04 into 10 raised to minus 5. Into 5 into 40, that is 200. Into a 600. So this 0, this 0, this 0. And this 10 raised to minus 5, the remaining is 10 raised to minus 2. So 2 into 1.04, that will be 2.08. And 2.08 into 32.5. So nearly the double into 10 raised to minus 2. The double, that is 65 range. So 65.04. Okay. So there is a 10 raised to minus 2, right? Now listen, the question number 42, this answer is nearly 20. You do it. And this is 4.065. Okay. So the concepts are same. There is a balance of calculation. I think you can do it. Okay. Ready. Okay, so the section electrolysis is over. We can discuss electrogalvanic cell.